Good morning, everyone, and good afternoon for the folks who are joining us from the East Coast. Thanks for joining us today on this exciting talk sessions we have on the world of smart city innovation in the energy sector, especially using data. So today we're going to have a couple of quick real life case studies in the world of smart cities and smart societies. First off, we'll have Jean Home, who's joining us from Los Angeles. She's going to be talking about how LA is using leading edge technology to create better access, as well as connecting the 4 million citizens who live in the city and the area around LA. We'll also have Jake Jian, who's one of our lead data scientists from Grid Dynamics, talking about how to respond to the growth of technology trends like electric vehicles and AI, and how that is impacting the energy sector. Overall, the goal of our session today is to talk about the importance of data science, especially around public sector, especially around infrastructure development. And with that, I'll like to introduce first Jean Home, who's right now the Chief Data Officer and Senior Technology Advisor to the Mayor's Office in Los Angeles for Mayor Eric Garcetti. And, if any of you is familiar with Jean, like she has a very prolific career. She's been named one of I'm forgetting the exact title, but she's won a lot of prizes in the data science space. She's actually been named one of the leaders in the data science space as well. And Jean, I'm sorry, like I'm forgetting the exact title of the they gave you, but she's been at the UN for almost 20 odd years now, and was at the White House in the previous administration as well. And Jane, with that, I'll give the floor to you. Yeah.
Sure, thank you very much. And it's a pleasure to be here. Glad to be talking to all of you today. I'm going to share a little bit about what we're doing in the city of Los Angeles and just really open to hearing what you guys are doing, what kind of projects you're working on, and the kinds of things that you're doing with artificial intelligence and new technologies. So let me just kind of talk a little bit about what it's like when you're trying to work with a city that has 4 million people, 500,000 businesses, 500 square miles in the midst of a pandemic, and trying to think about what it means to be a smart city in a time when there's so much need and concern. So Los Angeles is an amazing place in normal times. It's an amazing place today too. From the beach to the mountains, from Hollywood to our recent Lakers championship. There's wonderful things that happen around Los Angeles. During this time, the intent is to try to keep going with some of our smart city tasks, continuing to evolve with new emergent technologies, but doing so in ways that really address today's needs related to the pandemic, to the economic downturn, to the issues and challenges that people are having with just basic capacity and support that they need. And we've really transformed a lot of city services, and we're in the midst of transforming more. So we do this by using technology in ways that both make it easier to do some of the services that we have to, whether that's feeding animals at the zoo or running one of the world's largest airports at LAX, or the largest port in the Western Hemisphere at the Port of Los Angeles, or just making sure that streets are paved. All of these are services that we provide, and all of them are services that use different technologies in different ways, whether it's artificial intelligence or machine learning, blockchain, predictive analytics. A lot of these have been really focused on and stressed during this pandemic as we try to think differently about the way in which we approach what the data is telling us about the outbreak, what the data is telling us about equity of city services, and how we're able to make sure that the city services continue even during times like this. There are a few things in our infrastructure which make it easier for us to do this kind of thing. One is that we were the first city to have 5G. So for more than 2 years, we've been a 5G city. We started out with just 120 small cells, and we've moved up to over 2,000, and we're on our way to probably 6,000 or 7,000. This provides the ability to be able to make better connectivity across the city, but also to be able to gather and share data securely and making sure that we're protecting people's privacy and doing it in a way which helps to build digital equity across the city. We also have another important piece of our infrastructure, which is our open data portal. So the Los Angeles Open Data Portal allows people to get access to real-time information related to complaints and calls to 311, transportation issues and parking, information around public safety, environmental issues. I'll talk a little more about some of the work we're doing with NASA there. And just all the other information that's important for being able to get access to the services, understand how the city's functioning, and if you're a business, to be able to build your business services on top of some of the things that we're doing at the city. When you're in the transportation sector, it's really important for you to have access to a lot of that information about the state of streets and parking regulations. As you put all this information together, we also need to make it available in ways that are really understandable for folks. So this is an example of one of the dashboards we've been working on during the pandemic. This is related to our recovery dashboard. So this looks at 3 different things. It looks like the state of the city. So are the city services up and running? How many calls have we taken in the last week? How many miles of new pavement have we laid? How many construction permits are going on? It's important for people to know that business is still going, that things are still happening in the city, and that services are still available. On the other side, under health and wellness, we talk about a lot of the information you guys have seen. I think everybody's become a bit of a COVID data expert. And health and wellness is really showing 4 things. One is what our test rate is. We were the first city to provide testing to anybody, whether they had symptoms or not. Anybody could come in and get free testing. We have both drive-through centers, which are a very safe way of kind of administering tests. But because not everybody has a car or access to a car, we also have walk-up centers. Those are in some of the areas where we have high homelessness, or in communities where people don't have as much access to transportation. So we look at testing information, we look at hospitalization, and we work very closely with our hospital sector to make sure we understand if there's surge coming and surge capacity. We look at the number of cases and deaths. And we try to give this to people in a way that helps them understand what it means, as opposed to just a bunch of numbers. So you can see that things are sort of green, yellow, orange. Lines are going up or down. Colors are displayed in green if we're trending better. And so all of these are different areas and ways in which to convey that information using data analytics. And then in the middle, we're really talking about new programs that we've created that help our residents. We gathered almost $40 million in donations from individuals, and we put that out on debit cards to Angelenos right away. And so that went out to over 100,000 people. We now deliver 3 times a day meals to people who are particularly vulnerable, which is our seniors. So 60,000 meals a day are delivered to folks for whom going out in public can be difficult or high risk. And then we also, with Project Roomkey, are doing a ton of work around housing the homeless, particularly the elderly during this pandemic and those more vulnerable. We have a variety of other things going on that we note across the dashboard, but this is just a way of gathering data from lots of different places to make it more accessible for folks. The other thing we do is that the data science team is really a very broad and diverse team. So we have some data scientists at the city, but they're small but mighty in number. What we do is we connect to lots of data scientists and people working on data science in the public. So we founded the Data Science Federation, which is a consortium of 18 universities throughout Southern California and Arizona. And we connect those with not just the city of Los Angeles, but 88 other cities around the area to work together on projects around COVID, on air pollution, on diversity and LGBTQ rights, issues on making sure that we're getting information out to people about the environment. So these are just a variety of some of the projects, and you can see the pictures of some of the people in the Data Science Federation and some of our data angels. You can also see some pictures of kids, because I think anybody can be a data scientist. And so as we start to open up these opportunities, we're working with our libraries and others so that kids can come into libraries and be able to work on robotics and STEM projects, be able to start to work with data in a way that makes them understandable. There's a picture at the bottom in the middle that shows a child working with our Agents of Discovery app, which is the Southern California Explorer through our parks. And so you can go into a park and using augmented reality, you can catch the mountain lion and learn more about some of the different animals and biodiversity in Los Angeles. So whether you're a young person kind of understanding data and understanding science and technology and starting to interact in ways that are fun and engaging, whether you're somebody in school who wants to help the city, we have that Data Science Federation. And then we have our Data Angels program for people who are career professionals that want to come in and work on a specific project. So these things combine to solve a couple of different things. One is that we need to tackle some of these really tough city challenges without actually having all of the answers. There are 50,000 people who work for the city, but there are 4 million in the city, and there are a lot more outside of the city. So some of the best ideas are going to not come from City Hall, but are going to come from people in our community who are living these challenges and really want to make a difference. We also want to make sure that we expose our city staff to new technologies, new approaches, and a diversity of thought. And we want to make sure that students get a chance to work on things that are important and really change their neighborhood, to have an impact even while they're a student, and understand the power that they could have as a career in city government. But also just the power that data can play in helping to shape the outcomes and policies. As we put the groups together around our data science projects, we think about equity and ethics. So we have a digital code of ethics and a digital bill of rights that are drafted and should be going out shortly. This helps to guide how we look at data privacy and equity and ethical issues, algorithmic bias and issues like that. And then we also look at who's on those data science teams, right? So how do we make sure that we're getting rid of bias, that we're improving and supporting people across the spectrum? We want to make sure that we're doing that because we have diverse teams. So initially, when we started the Data Science Federation, there were a lot of men proposing projects and leading projects. And what we found very quickly was that when we asked some of the women involved in the network to step forward, that we shifted that. So now we have about 80% of the projects that are submitted by city departments submitted by women, and half of our university partnerships are led by women. Equity is when you look at it, a situation, and then you work in an intentional way to try to make things more equitable for folks. So what are some of the projects that we're working on? Well, one of them is called Know Your Community. So this is an app that helps people understand not what's happening in Los Angeles writ large, but in their community. So in a city of 4 million people, we all live in smaller neighborhoods. And those neighborhoods are where I want to know, like, what's the traffic like today? What's my air quality? Where can I vote today? Has anybody called in that pothole down the street? Is that graffiti getting removed? And so this is a way to just very, in a hyper-local way, put information together for people about their neighborhood. And it's been really useful because then it also helps for people to know where they have a voice to either vote or go to their neighborhood council or to their city council person to be able to express something that's important to them. We also have a very popular app called MyLA311. This one allows you to either call 311, that's a 3-digit phone number like 911, but for non-emergencies, to call 311 and report anything you need, as well as being able to use the app to create a service request. So it immediately goes into the queue to be able to get something fixed. Or you can just call and ask for information. We support about 140 languages across the app and the call center. The other project we've been working on is the first earthquake early warning project in the United States. So Shake Alert LA works with the US Geological Survey, who has sensors in the ground up and down the west coast of America. And those sensors detect when shaking happens for an earthquake. It doesn't predict that an earthquake happens. It notes that an earthquake has started happening, and it can project and predict the magnitude of it at any given location around the state. And so what we do is we then send an electronic signal faster than the ground shaking travels to be able to get that information out to people that an earthquake is coming. It's going to be either mild or severe, and to get prepared. And so you get about a minute's warning. It's not a huge amount of time We were the first ones to be able to successfully do this, and now we've been helped to blaze the trail for other application developers to be able to do this, and also to use automation to be able to open doors or shut down fuel valves and other actions that might need to be made in advance of an earthquake happening. One of the areas that we've been specifically using artificial intelligence on is around transportation. So in this case, we're looking at the issues around how we're counting pedestrians and bicyclists in the public rights of way and making sure that we're being as safe as possible. So you can see in the video here on the side that we're looking at, we can't do facial recognition. This is not for that. This is just literally counting if there's somebody with a wheelchair, an e-scooter, a bike, or walking, so that we can in real time give that information to our traffic lights and be able to accommodate more time for people to cross the street when they might need it. Part of this connects to a data mobility specification that we've been working on. We've actually just open sourced this broadly and made it available to lots of folks. We've had over 50 cities adopt this. So this is a way to share anonymized data with different transportation companies. We're focusing first on e-scooters. So we need as a city to know a little bit of information. We need to know where people pick up and drop off scooters, because we might need to make something different in the infrastructure, right? In the environment or the curb or different areas so that people can safely drop off or pick up scooters. We also want to know if the scooters have power, because if suddenly we have a bunch of scooters without power that are left someplace, we want to be able to notify the company and make sure that they're going to get moved or serviced. We don't care who's riding the scooter, so we don't actually want any personal identifying information, but we do want to have this sense of where they're moving. And what it's done is we've issued over 38,000 permits under this new specification. And it's really laid the groundwork for how we're working forward into the future as autonomous vehicles are coming on the streets of Los Angeles. And soon autonomous airborne vehicles will be moving people and goods across the skies of Los Angeles. So by having this smaller place to start working with around scooters and sharing data that's anonymized and people's privacy is respected, lets us build a framework for a larger piece. Another area where we're using machine learning particularly, and a little bit of predictive analytics, is on a project we have with NASA, the space agency, around predicting what we breathe. So this relates to air quality. We combine satellite data from various NASA and European Space Agency satellites with the data from our smart cities ground sensors and Internet of Things sensors. So these could be on police cars or streetlights or out by our landfills or on sanitation trucks. And these collect, and it's not all owned by the city, some of them are owned by other regional governments. And we collect this information so that we can create an integrated air quality map down to a very local neighborhood level. And by doing this and having this data for a long period of time, we're able to predict what the air quality will be like tomorrow and next week. This is really important for people who have asthma and other issues, especially now during COVID, when we know the heavier impact of COVID on people with COPD and other respiratory illnesses. We want to make sure that we're helping people not only be aware and working with their health companies to give them that data, but we're also working to see what are the most effective ways in which we as a city mitigate bad air quality. Is it regulation? Is it pollution? Is it gasoline changes? And so we can see the effect over time of each of those changes in a neighborhood and be able to assess which is going to be the best way to continue to tackle this in the future. We also have used machine learning and artificial intelligence trying to understand more about COVID. And so we recently held a global challenge. Over 400 people from 4 different continents competed on this. And the idea was, could we create a risk score for a location based on how many people are going around there based on transportation data, what the infection rate is in that neighborhood, the density of nursing homes, and a whole bunch of other variety of issues. And then the winner was at USC. And so they've open sourced the model, and we're working to connect that to our contact tracing work. And then finally, as a city, we really are committed to a broad range of work that connects technology and data in ways that improve people's lives. So we've adopted the United Nations Sustainable Development Goals. These are 17 global goals that mostly countries adopt, but in our case, our city is the 13th largest economy in the world, and we have a huge number of folks here, and all of these things, decreasing poverty, eliminating hunger, getting quality education, having more climate action, all of these things are important to people in Los Angeles. So we've created a dashboard that shows the indicators behind each of these, what's going on with those, how we're progressing or not towards each of these different areas. And it's really a community effort. So some of this information comes from organizations like the United Way. Other information comes from the city or the county or the state. Other information comes from citizen science activities. Again, this is one of our Data Science Federation projects where university students come in every summer, help us kind of move forward on some of these issues and really look at equity across this. So we're doing a lot around all of these kinds of things. We're also doing work with we're in wildfire season right now. So some of our work around drone technology and the use of wildfires, both in preventative and in ongoing viewing of an active fire. And of course, our work towards autonomous vehicles on the ground and in the air. So thanks for listening to what we're doing in Los Angeles. I look forward to hearing your questions, and back to you, Jake.
Thanks a lot, Jean. That was like quite a few like really interesting thoughts. Before we go into Jake, I have a top level question, which is like it seems like there's a lot of like these data libraries which are available to the citizens, right? How are you also like creating awareness about their availability? Because a lot of these things like they're really cool, but I had no idea that like even when you're walking on a street, that's being factored into the street lights and stuff.
Yeah, so I work with the Chambers of Commerce. I was just speaking to the Hollywood Chamber of Commerce yesterday and a couple weeks ago with the LA Chamber of Commerce. So we talked to businesses and entrepreneurship groups. And then we also try to like build it into services. So it's less important necessarily that people are aware of the data. I mean, it's great, and we want to make sure it's accessible and machine readable and human understandable, but we want to make sure that the data is being used in ways that deliver better services, right? So if you call into 311, your vote essentially on what you want fixed in your neighborhood, whatever you're complaining about, goes into that database and gets accumulated and gets acted upon. So we really try to build these into operational services as much as possible. And then I used to manage data.gov for the US government. And so we also integrate all of our city data into the federal data repository, which works as an aggregator for lots of different data sources.
Got you. I think there's a related question, and because it's so related, I'll maybe try to cover it right away. Is there a unified location for APIs to pull data from the LA Data Science Federation projects?
Yeah, so the Open Data Portal, which Lucas nicely connected here, data.lacity.org, has an API for every data set. So you can just access the API or the data or the map, depending on kind of what it is. And then I'm going to drop in the URL for the Data Science Federation projects. And so there's a selection of them here and then available through open source on the city's GitHub site as well. So if it's actually something that ended up as an open source project, some of them are analysis and reports, but if it ends up as an open source project, then it gets up on the city's GitHub.
Got you. So I have a couple of follow-up questions on the same. There is a concept, or at least a movement, which is kind of becoming popular, which is like citizen data scientist. What are your thoughts on it?
Yeah, so when I was at the White House, I put together a project. Let me just pull up the URL really quick on the Federal Citizen Science and Crowdsourcing Kit. And it's a really great guideline of how to work with citizen science groups and be able to help them collect data in ways that are useful to scientists, right? Because we have lots of citizen science groups and they're sometimes focused around learning, which is great. But sometimes they're like, hey, we're really collecting data about like monarch butterfly migration or bird watching or air quality. And so we want to make sure that their data that they gather is done in a way that's rigorous enough for the scientists, but still approachable for, you know, a non-data scientist. Our project that I mentioned with NASA around air quality has a citizen science component. So in that case, what we're doing is we're working with Purple Air and SafeCast, which are two small kind of air quality sensors. And we'll be giving away some of those to people in neighborhoods that are particularly vulnerable or don't have a lot of air quality sensors, and asking them to be part of collecting that data and understanding that data.
Okay, perfect. And before I introduce Jake, I did want to cover, like, you know, some of the things which I didn't remember on the top of my head, but now I have them in front of me. So Jean's had like a prolific career, and the things I was trying to mention, but I couldn't like remember on the top of my head, was like she's been at NASA, and she's gotten the Exceptional Service Medal for Leadership twice. She's been named one of the top 50 women in tech. She's also received the NASA Achievement Award because she's worked on both the Galileo and the Voyager space projects. And then you've also been involved with the Academy of Digital Arts and Sciences, where she's like you know, been like she's gotten 3 Webbies with them as well. And she has she's been a part of over 130 publications. So thanks a lot, Jean. Like, really appreciate, you know, you taking the time. We'll come back to more questions and answers after Jake's talk. So in the meanwhile, if any of you have any thoughts, questions, suggestions, please feel free to type them out in the chat window. With that, I'd like to introduce Jake real quick. So Jake's our resident lead data scientist. He's you know, he has over 10 years of experience working in the energy sector. He comes from like economics / statistics background. He's worked in the on Wall Street a little bit, and then he moved into the energy sector for over 10 years. And over the last few years, he's been more and more like getting involved in let's say hardcore data science, especially focused on like artificial intelligence, deep learning, neural networks, and robotic process automation. And Jake's today going to be talking about how do you predict like the disruptive effect of a technological or cultural change, like the adoption of EVs. And with that, I'll give you the floor, Jake. Let me know, like.
Thank you, Jean, and thank you, Pramod. So it's a pleasure to have this opportunity to share one of my project experience. Not long ago, I led a project in the electric vehicle space. It was an interesting project. In that project, we used machine learning methodology to try to identify unknown EVs according to their consumption pattern. So I would like to share this project experience with you guys, but let me start with sharing my screen. Just one second. All right. So before I dive into the use case, I want to spend a couple of minutes talking about like the why we care question. I pull up some data on the global EV sales all the way from 2014 to 2019. But as you can see it from this chart, right, the EV penetration rate is actually almost like doubling every other year. In 2014, we have 0.4% of the total sales that are EVs. In 2019, we have 2.5%, which is quite significant. And with this rate, the low impact on the EVs are going to be quite significant for the utilities in recent years, and probably in future recent years we would have more and more EV owners in the lower regions for utilities. So let me first introduce the use case. the use case is we have this problem that in a utility, there's a lot of EV owners which are unknown to the utility. We want to identify them, and we want to analyze the low impact on the EVs based on the AMI data, which can provide hourly load data. This is an interesting use cases, and we first analyze these use cases by addressing some fundamental questions. So the fundamental questions are, which I will cover in the next slide, more detail, but just to briefly mention the fundamental questions are, we want to know when are the consumer charging their electric vehicles. We want to understand what is the magnitude, because the battery model can vary from like a supercharging model like Tesla model. They would have like a higher spike and shorter duration, and a Toyota Prius would have a lower spike and longer duration. So we want to understand those magnitude. And we also want to understanding the impact on the transformers. Because in the utilities, the EVs have a very big impact on load. It's going to affect some of the transformers and cause outages. If we understand how many EVs are on a single transformer, we can create alerts and trying to do preventive maintenance before system failure. And then at last, we want to understand, where the EVs are located, right? This is very good for the load analysis or load planning for the utility. So, some of the business value that we created is like, we first, right, we help the utility to understand the EV penetration. And we definitely help to the peak load analysis, which because a lot of EV owners are actually charging their cars after they got home, so it creates like higher peak, evening peak, high evening peak for the consumer profile. So our EV study can definitely help to assess that how much like peak load risk is for the utility. And we also help the marketing campaign manager to target EV owners because before they have pretty much like send the offering to everyone. They have rate incentives for EVs on their demand response program, and they pretty much cannot target EV owners, so they might just like send it to everyone. So with our machine learning model, we are going to identify the EV owners by their consumption profile. So their hit rate will be much more efficient, right, for the marketing managers. And then, as I mentioned, we would also have some help in preventing transformer outages. So let's take a more detailed view on the key questions that we addressed previously. So when people are charging, it's actually a consumer behavior question, or we want to understanding what are their consumption habits, right? So people could be charging their cars in the evening, because basically when they got home, they find their tanks are half full, their battery was half full, half empty, and they want to charge it right immediately. And it's also a study on how do they respond to rate incentives. Utilities have a lot of demand response program that they're trying to shift the on-peak charging to the off-peak. Right? Obviously, off-peak energy in the wholesale level will be much cheaper than the on-peak. So they kind of want to like shift the peak. So they design some rate incentive programs. But how these customers are responding to the rate incentive program, right? It's a very critical question to understanding when people are charging and what can shift them, right? On the second question is where people are charging. There's mainly two types of charging areas. One is the charging station. Tesla has a lot of charging station. nowadays a lot of offices actually they provide chargers in their parking lot. So a lot of consumers are charging their vehicles when they're in the office. So that is something to keep in mind. But I think like the majority of the EV chargers are still charging their cars at home. So those are a lot of home chargers in the residential homes that we found. There are also like chargings in the parking lot of the residential buildings, but their charging time and behavior will be very similar because they usually charge their cars when they get home from work. And then the last question is, the impact, low impact. How big is that, right? So obviously, at the individual level, it's going to very depend on the battery model or the car model or the battery model. As I mentioned before, some cars like Tesla, they have superchargers, so you're going to see a higher spike in the consumption pattern, but probably a shorter duration. Versus a normal car would have a lower spike but longer duration to charge the battery. And we also would like to, understanding also the frequency of the spike, because from, considers to consumers, their frequency of charging will be different. Some could be charging, more frequent if they're daily commuters. Some might be charging less frequent if they just use the EV as a leisure car. And also the frequency will help us to distinguish the electric vehicles from other huge large appliances like a heating pool, right? They can create similar spike pattern, but the frequency is not going to be as frequent as EV owners are charging their battery. And in the end, there's an econometric study that we can do in the EV growth forecasting. So EV growth forecasting is a very important study to understand the EV penetration in the future. Because like this to understanding the EV growth, we have to understand a lot of things. For example, the economic growth, the EV industry, what is the new technologies on battery, what is the cost on EVs, what are consumers' preferences in buying EV car versus buying a traditional car by burning gas. So that is all taken into consideration, and then we can build our EV growth model to understanding the future penetration. So this is an interesting slide, I think. What I want to show you is a typical EV charging pattern versus a normally EV charging pattern. So typically, when the battery was charged, it quickly reached the peak. The first hour is usually the highest magnitude, and it decreased like pretty quickly. Over the few hours, we can see the EV spike is pretty much dropped to zero. However, in reality, we actually find a couple of anomalies to this charging pattern, and the most common one is a two-peak charging pattern. So instead of having the first spike, it actually has two spikes. In spike detection, kind of anomaly detection mechanism, it's very easy to consider this as like a two charging pattern instead of one. But actually, if you look at the duration of the spike, it's actually happened in a couple of hours, right? Connecting hours. So this can be a couple of reasons. We could not find like what is the root cause for creating this, but there's like a lot of speculations on why this can happen. So one speculation would be EV owners are all very likely to have solar panels as well. And the solar generation, could cause the drop in the spike because it's intermittent power. Another speculation is that the EV owner could have other larger appliances like a heating pool, right? When they're charging their EV, the other appliances might also taken in place. So it could be like some disguise. I would say disguise patterns. But as we are trying to identify the EVs, we pretty much consider two factors. One is the magnitude, the spike magnitude, because usually we'll find that the EV charging will be above 3-4 kilowatt hour. That kind of spike would be EV caused by EV charging. A smaller spike will probably caused by other appliances. And the second is the duration of the charge. Usually we will need a couple of hours to complete the charge. So despite of these anomalies, we can actually fix some of the anomalies in the final result, and then we'll consider it as like a one charge, right? The EV on the EV. So after we understanding the charging pattern, let's move on to the modeling framework. So this shows a very high level of modeling framework that's in the project. So on the left-hand side, there's a bin. So it's pretty much like contains all the data we need. We need the MI data. We need hourly load data. We need customer profile data. We need geolocation data to understand where the EVs are located. And after we collect all the data, we start to building our machine learning models. The first big model that we want to build is a spike detection model. A spike detection model is an anomaly detection model that from the consumption we want to detect the spikes in the consumption pattern. For detecting spike, there's a lot of anomaly detection methodology we can use. In this specific use cases, we use a Riemann model, trying to get a prediction on the next hour. But if in fact it's a spike, we would check the magnitude of the spike, and if it's greater than the threshold, we would consider it as EV charging pattern. And after we got all these spikes, we move on to a classification model. So our goal to classify the EVs and non-EVs are, first, we want to understand whether this can be possibly a EV owner or non-EV owner. And then if it's a EV owner, what is the magnitude going to be like? Because the EV owner can have a variety choice of EV models, and their charging magnitudes and duration, as I mentioned, would be totally different. So we would use a classification model. As you can see, we use a decision tree model to take features like spike magnitude and frequency and to generate an output of EVs and non-EVs. And if it's EVs, like a high magnitude EV or medium or low magnitude EV. And after we do that, we have a pretty clear idea of the EVs or non-EVs based on the consumption pattern, and we would do our model validation. Our model validation is mostly depend on two criteria, which is one, the false positive, which is we identify as a EV, but a testing sample show it's a non-EV, and the false negative, which is the other way around, we identify as a non-EV, but it's in fact a EV. So in our project, we test these two criteria to evaluate the model. So this is my last slide. I want to show you some data visualization examples, also the results of this study. One thing I want to note is that we're using fake data here because we don't want to show real data in a presentation. Those are confidential. But we can still get an idea of what our models can do for the utility or power provider. So on the left we have a locational map, which we can show where the EVs are located. As you can see, there's three different colors of dots in the map. Those are high magnitude EVs, medium spike magnitude EVs, and low magnitude EVs. And this can help the utility to identify their EV owners and plan accordingly. So this is answering where the people are charging question. On the right-hand side, you see a dashboard. We have a couple of interesting bar charts here. We have the transformer count by EV. So this is for the utility to decide where to send their technicians on maintenance or preventive maintenance work. Because the more EVs are in a transformer, the more likely that the transformer will cause like transformer outages. So as soon as we identify that information, they can send their field technicians and do preventive maintenance work. The spike detection, the spike distribution chart is showing when people are charging, right? So we have 24 hours, and then we can see the spike distribution in these hours. And again, like I want to emphasize that this is not real data. But in this chart, it will show like the customer behavior or customer charging habits, and this will help utility to understand when EV is most likely to charge, and if it's affecting the evening peak, what should they consider to shift the demand to off-peak demand. And lastly, we have a chart on like EV by cities. This is more for like low planning, because we can like understanding how many EVs are in such a city, and currently and future prediction. So we can do better low planning according to that information. So like all these charts will help the business analytics for this utility. So with that, that concludes my presentation today. I want to thank you again. So I'll pass it back to you, Pramon.
Thanks, Jake. Okay. So we have a couple of questions here. And before we dive in, so Jean, like there's one more question for you before we like dive into some of the questions for Jake. What are some of the solutions, paid or free, to obtain good quality availability for end user of LA data projects?
I'm not really sure what they're asking there. I'm wondering if they're looking at what kind of tools people are using, or maybe what kind of platforms we're using. So I'll answer both. Okay. We provide data over Socrata for open data, and then and the open APIs. We use GitHub if we're providing source code, or the mobility data specification, for example, is available through GitHub. And then we use Esri for our mapping service and the mapping layers. And we integrate that a lot with the county work because it's very, very connected. People consume that data in lots of ways. So they might be using, like downloading the data and then running it through Python or R, or some other tools like that. If it's an Esri layer, they might be putting it into their own ArcGIS map. So we see people just consuming it in different ways. A lot of people are using the APIs, particularly around parking. There's a ton of parking apps out on the market right now, looking at curb availability and parking capacity. Got you.
Okay, so back to you, Jake. So Mike, I have a quick set of questions for you. My first question for you is like obviously like the one which everyone's probably thinking is how do you factor in like 2020 into like a forecast like that? Like how does COVID like change something like this? And also like now we have the 2040 verdict or 2040 like I'm not sure what the exact word is, but like in California, basically all new cars will have to be electric after 2040. So how does the model like handle things like that?
Right. So I think there's two questions, right? Let me tackle one first. So one by one. So one is how COVID is going to change the EV forecast, right? So I think COVID changed the way people are working. That's probably the biggest shock to the EV industry. Because like people are more working remotely, right? The need for cars is less. So this is definitely have an impact on the EV because like people are going to probably demand less cars. People probably consider buying new cars, and now they would think, oh, okay, so I'm working from home anyway, right? Why do I need a new car? So this is going to affect sales, but also another impact would be because this demand on cars are changing. It's also changed fuel prices too. Fuel prices is a very important driver in the EV sales. Because the cheaper the fuel prices are, the cheaper it is to own a traditional car comparing to an EV car. So that is also taken into consideration. So in terms of like 2020, I think it's a mixed effect that affecting the EV growth analysis, and we would do a deeper dive into that, right, in order to answer that question. But this is my initial thoughts. Yeah. So the second question is like I think it's very interesting question that you bring this up. On the EV cars, policy definitely play a very, very important role in the EV industry. One is the tax credit that we have seen is affecting the EV sales a lot. When I was doing the project, actually we looked at the tax credits and the EV sales. The phase out of we can clearly see like a drop of the EV sales when we are reaching the phase out of some of the tax credits. This is because for consumers, it's more expensive to own an EV. And also that the fact you mentioned that California would have some requirements on electric vehicles. It's definitely going to affect the consumer purchase behavior. So this is on the other hand will have a positive impact on the EV sales because it would boost the sales up.
Got you. So I have a broader question, and I think this is something which applies to both you and Gene, is that it seems like 2020 has hit a hard reset on data, right? Like there are companies which have been collecting data for last 10, 15 years on consumer behavior, on user trends, but a lot of these trends may or may not change permanently, and we don't know one way or the other where things are going to go. So my question to you is, like, as a city, maybe as a state or as a company, how do I then, like, do I start from scratch? How do I weigh in old data versus new data in this like state of high uncertainty on what is going to happen next year? Yeah.
I was just going to say, I think that the data changes a lot, but there's still data. So like when we look at air quality data, we have to kind of put it in context, right? So air quality data has changed very little. I mean, seasonally it changes, but it's changed very little over the last decade, except getting slightly worse over time. But then when we look at it during COVID, right, there's this massive transformation because everything stopped in March and April. And so the air quality suddenly cleared up in many ways. And I think that the trick now in these really kind of dynamic and changing times is to try to understand, one, what effect the bigger environment is having, the bigger world thing, the things happening in the world are having on the data that you're looking at. And secondarily, when we start to do things like predictive analytics or AI or machine learning, you have to take that into account because you cannot train a data set on 2020 data and think that that's going to be indicative of normal patterns. So I think it's really, it really brings forward the fact that we have to have human intelligence combined with all these great tools and technologies and AI in order to be able to make sense of what we're seeing.
Okay, perfect. Jake, any thoughts from you?
Yeah, I think the biggest challenge in the COVID environment is how to forecast load. because in the energy industry, low is most low forecasting models are done on weather-driven model based on weather-driven model, but the COVID really changes the consumer pattern. More people are remoting from home. Less people are in the office. So before you can see like a typical residential profile would have 2 peaks, one in the morning, one in the evening, and the commercial profile would have usually 1 peak, during the business hours. But nowadays everything's changed. More and more people working from home, so you're more seeing like much more demand during the daytime for residential consumers and less for the commercial customers. So I mean, this is definitely creating a different load pattern for the utilities and power providers. And then in order to forecasting load, we can no longer use the traditional methods where we just bring the recent data to the model and trying to do the analysis. We would also considering the COVID factor. So one of the things that we have been doing is that we would utilize some of the public sector information, like what happened in Asia, because the COVID impact actually happens first in Asia and then to the United States. So we're actually liaising that data and trying to figure out what are the changing patterns, and use that to create a machine learning model to adjust COVID.
Okay, perfect. Okay, I think that's all the questions there are right now. Any closing thoughts, Jean, Jake?
I'd just like to, encourage everybody to explore data, to use it in new ways, to think about the opportunities that the changes in the world around us are really causing, and think about if there's a way for you to take action that will help to, help others, or to be able to provide better insights.
Jake?
Yeah, I think like I want to call like data scientist Andrew Wu. He said like the data science is the new electricity. Nowadays, a lot of traditional industries are affected by data science. The big data makes it possible for a lot of industry to disrupt the old business and trying to utilize data to move the business to a next level. So I would like to meet everybody in the industry and share some thoughts on the data science field. And again, it's a very it's a pleasure to speak in this webinar, and thank you very much.
Perfect. Well, thanks everyone. And there's another question which I noticed, which is on will the recordings of these sessions be available? Yes, the webinar will be available as the video recordings will be shared with the attendees of the webinar, and we'll also share the contact information. So feel free to stay in touch, and if you have any other questions, feel free to reach out to us. And with that, I'd like to thank you all for taking the time, and hope you have a nice